Okay, so we're going to look at selecting a systematic sample, and we're going to focus on Beijing 1987, and we'll look at daily mean wind speed. So if we select the data first of all, so copy down to the bottom there, and if you just look at the count at the bottom of the screen, that will tell me how many pieces of data we've got, which is kind of useful. So there we go. We've selected 185 cells, but that includes the title cell here. So we've selected 184 numbers. So Control C, and let's just put that in the new spreadsheet for now. I'll put that in the second column. There we can put it at the top for reasons which will become clear in a moment. Now, a systematic sample, we select every at regular intervals throughout the list. So let's just take a new page there. Now we've got 184 values, so if we do 184, and if let's say we want to take a sample size of 40, so sample size equals 40. So to find out how what intervals we need to take data points from the list, we'll divide by 40. 184 divided by 40 turns out to be 4.6. Okay, so we want to take data every 4.6 values. Now clearly we can't do that because it's a decimal. We can't take it every fifth value because 5 times 40 is 200 and we wouldn't have enough data points, so we'll take it every fourth value. So take data points every fourth value. Okay, so what we will do is we'll number our data next, and I'm just going to illustrate a bit of a problem really with systematic samples if we do it this way, and then I'll show you a slightly better way we could do it afterwards. So if we number our data, we're going to take it every fourth, so every fourth point. So if we number our data 1, 2, 3, 4, and the quickest way actually to do this, if we copy that and then paste it again, so we've got 1, 2, 3, 4, 1, 2, 3, 4. If we select all of that, sorry, and then select this little square at the bottom and drag it down right to the bottom of the data set. There we go. And then it fills in these funny numbers, but don't worry too much about that. If we select this and then put copy cells, it'll just go 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4 all the way down. Now we're going to, let's just put that on manual, the calculation option on manual. We're going to do a random number. We're going to select a random number between 1 and 4. This is the way the book tells you to do it. Select a random number between 1 and 4, and we've got the random number 2. So out of those first 4 bits of data, we'll select the second piece of data, and then we'll select every fourth piece of data from that. Now the way we've numbered this, that will correspond to that one. So that'll be the second piece of data in our sample, and then the next one will be that one, the next 2, because we're doing it every 4, etc., etc. So that was the point of putting this list in here, because now if we select that and we sort it, so custom sort by column A, smallest to largest, that's all fine. It'll put all the 1s together, and it's the 2s that we're interested in. So this is going to be for my sample. So I select all those 2s, so it finishes there. Now just notice we've got 46 pieces of data. Let's just copy that for a second. Put that somewhere else. Let's put that over here. So here's our sample. And we've got 46 pieces of data. Now you might just want to stop and think a little bit about why that is. Because we wanted only a sample of 40, but because we did that rounding and we rounded 4.6 down to 4, we took it every fourth piece of data, which meant that we actually ended up with more than 40. So what we could do is select the first 40 pieces of data. So take those, and then you copy them over here for now. So now we've only got 40 pieces of data. You could copy that into GeoGebra and start doing some analysis, or do whatever you want to do with it. The problem with that though is these pieces of data here are not going to feature in the list, and if you think about the method, that means that these pieces of data at the end of the list are never going to feature in a systematic sample, and that doesn't feel very fair, because if, for instance, in Beijing you had some kind of seasonal weather event which meant that at the end of October there was always a very windy season, for instance, then you would obviously be excluding those results from the way that you were sampling. So there's a bit of a problem with what we've done as a sampling method, but that is the way they explain it, how to do the sampling in the book. We could nuance it slightly to make it fairer, and to include those, is we could say we want the possibility of selecting that last event. So I'll just explain how we could do this and perhaps do it again. So we could say we'll select our first piece of data randomly, but not from the first 4, from a bigger number, and then we'll select every 4th after that, so that we've got the possibility of selecting those pieces of data right at the end of the list. Now, if I just do a few calculations to show how we'll do that, because we need to know from what kind of list do we need to select the first piece of data, and then every 4th, so that we include all the pieces of data. So we'll select the first one from a big list, and then we need to select another 39 pieces of data at intervals of 4. So 39 times 4 turns out to be 156. So what that means is that the last piece of data, if I numbered all my data from 1 to 184, my last piece of data, its number is 156 bigger than the first piece of data that I selected. So if I now I want that possibility that I can select the very last piece of data. So if I do 184, take away 156, I get 28. So what that means is I need to select my first piece of data randomly from the first 28 pieces of data in the list, and then if I select every 4th one after the 28th, or after a number between 1 and 28, I've got the possibility of selecting right through the list, and I don't have that bias we talked about earlier. Okay, so how can we do that? It's a little bit more complex. So we've got to do that calculation first of all. If I go back to my data set, then and have we got it pasted somewhere in completion? I think that's all of it, isn't it? So there's my data there. Now let's just delete that. Let's put another column in though. So what we'll do now is, instead of selecting a random number between 1 and 4, we'll select a random number between 1 and 28. So 10. So we're going to start at the 10th value now. So that's my 1st, 2nd, 3rd, 4th, 5th, 6th, 7th, 8th, 9th, 10th. And I'll just do what I did before, but I'll start there. So I'll just call this 1, 2, 3, 4. I'll do 2 versions of that, 1, 2, 3, 4. If I copy that, and then I drag that all the way down to the bottom, I'm going to get these weird numbers again, but it's okay because I can just go copy cells, and that does 1, 2, 3, 4, 1, 2, 3, 4 from there. Now that's my 10th piece of value, so I want to select another 4 after that, another 4 after that. So if I just get these ones, and I'll sort them by column A again. It's a bit weird. Okay, I can't sort by column because I haven't got the whole column selected. Okay, cancel that. Let's go back. Yeah, so I'm going to sort by. I'll try sorting by ones. Let's just see if that works. So I've got all the 1s together, got all the 2s together, all the 3s together, all the 4s together. Yeah, that's what I wanted. And I'm going to select all these 1s. So that's from the 10th value, with the 14th value, the 18th value, 22nd value, etc. From my original list. So Control C, and then Let's have a new one. Let's paste that in here for now. So there's my sample, and you'll notice I've still got 44. It's still to do with the rounding, but at least with this method I had the possibility of picking those ones at the end of the list, but I was still going to need to get rid of these last 4. And if my random number had been bigger, so it had been closer to 28, I might have only selected, I would have selected fewer amounts, but still I would have got 40 in total. So there we go. That's a totally fair way, fair way where every member of the population of Beijing wind speeds in 19, which year was it we did? In 1987, every member has got an equal chance of being selected. So that's the best way to take a systematic sample.